Hi guys, welcome to our last lesson of this unit. So you know that you're going to have an assessment that comes up soon, but let's look at this lesson called Classifying Numbers. This one isn't too hard at all. All right, all real numbers, which is what we've been working mostly with, are either rational or irrational. It is not possible to be both. It's one or the other. Therefore, when classifying numbers, step one is determine which of these categories your number falls in. Always. That's got to be your first decision. Every number is either going to be classified as rational or irrational. Rational numbers sometimes get additional names. All right, so we're going to fill in some examples of each. Let's start with the list that's short. Irrational. Okay, irrational numbers. Pi. Pi is a number that goes on forever and ever and ever, never repeats, never terminates. That's why it's irrational. It cannot be written as a fraction because I can never determine the very last place value to put in the denominator. All right, other numbers that go on forever and ever and ever without repeating. Square roots of non-perfect squares. Those numbers that don't fall on our diagonal because there is not a whole number times itself that equals those numbers. Okay. There's a few other irrational numbers, but sometimes they show up just in this form, maybe 1.238765993. You see it going on, no repeating. So that is irrational. Okay, so there's not too many to look for irrational. Most all other numbers are rational. So let's look at some examples. Nothing, the number that represents nothing is irrational, 0. All negatives, so -1, -2, -3, they're rational. All positives, 1, 2, 3, continuing, they are rational. All decimals, so 1.2, 0.5, etc., they're rational. All fractions, 2/3, 3/4, they're rational. Okay. Now, there's some tricky ones. Sometimes a number or a value will have an irrational number in it, but when you reduce it, you realize it reduces to be a rational number. For example, let's do one with pi. We know a number, pi is a number, over itself always reduces to be what? The number 1. So see, I can use some irrational numbers and turn them or use them to express a rational. So be careful. Don't always assume if you see pi, it's going to be irrational because it just depends. Here's another one. The square root of 31 squared. We know those symbols undo each other, and the result would just be 31. And 31 is a positive number, so it's rational. So a few of these we have to think on, but they don't try to trick you too much. All right. So if your number is irrational, then it does not fall in to any other category. If you get irrational, you're done. However, do not be fooled by the tricky ones. And I give you again that example of pi. We know it's irrational, but pi over pi reduces to 1. So the value 1 is rational. We would have to classify this as rational. All right, classifying rational numbers is just about knowing the correct questions to ask about the number. So I made a chart. So the first question you ask yourself, is it a decimal or fraction that does not reduce to a whole number? If the answer is yes, stop. It's rational only. If the answer is no, then ask yourself, is the value negative? If the answer is yes, stop. Classify it as a rational and integer. But if the answer is no, you have one more question to ask. Is the value 0? If the answer is yes, it is rational, integer, and whole number. But if the answer is no, it's rational, integer, whole number, and natural number. Natural numbers are also known as counting numbers. We don't start out counting with 0. We start out with the number 1, then 2 blocks, 3 blocks, 4 blocks. Get the point? Those are natural numbers. Whole numbers are all our naturals and 0. Okay? Integers are any whole numbers opposite. So -1, -2, -3. And then rational in general includes any number that is irrational, not irrational. All right, so let's practice our questions. First question, is it rational or irrational? Well, we're classifying 1/4. That's a fraction. It falls on the rational side. So now our next question to ask, is it a decimal or a fraction? The answer is yes, so we get to stop. We call it rational only. I suggest you follow along with that chart as I do this. Okay, classify 2π. Remember, we got to get it, is it rational or irrational first? Because if it's rational, we use our chart. Okay, we see the number pi. Does it reduce? Well, no, 2 times pi just is pi bigger, so it still goes on forever. So pi is on the irrational side. We don't need the chart. We just stop and call it irrational. All right, classify 16. That's not irrational because it's on the rational side. That was a whole number. Okay, so now, since it's rational, we use our chart. Question 1, is it a decimal or fraction? No. Go to question 2. Is it 0 or is it negative? No. Question 3, is it 0? No. All right. Since we are now to the point that we're at the bottom where no, it's not 0, your answer is rational, integer, whole number, and counting. All right, let's classify -16. It's rational because it's not pi or the square root of a non-perfect or a decimal that goes on forever. Okay. All right, square root of -16, is it a decimal or fraction? No. Next question, is it negative? Yes. And you see on the chart to stop. It's rational and an integer. All right, classify -1.25. That is a decimal that stops, so it's rational. Is it a fraction or decimal? Yes, so we get to stop. When we say yes to fraction or decimal, doesn't even matter if it's negative at this point because we're just looking at fraction or decimal. When we say yes to that, the chart tells us, call it rational only. All right, classify the square root of 36. When we see the square root symbol, we need to ask ourselves, is it a perfect square? And it is. If it's the square root of a perfect square, it is rational. We need to find the root. The root is 6. So we're actually going to classify the number 6. All right, so on our rational chart to use, is it a fraction or decimal? No. Next question, is it negative? No. Next question, is it 0? No. So that leads us to seeing it is rational. I'm going to abbreviate, integer, whole, and a counting number. All right, one more or two more. Square root of 21. When you see the square root symbol, is it a perfect square? No. When it's not a perfect square, remember that's irrational only. And finally, classify -15 over -3. Our question when we ask ourselves about decimal and fractions on the rational side, because I know this is rational, is does it reduce to a whole number? And this does. It reduces to +5. So I actually have to reduce it first and now classify 5. So was it a fraction or decimal now? No. Is it negative? No. Is it 0? No. That means it's all 4. Rational, integer, whole, and counting number. All right, I think if you will keep that chart out in front of you, you'll realize that it really goes pretty fast. Remember on the chart, that's used for when you decide it's rational. If you decide it's irrational, just stop at irrational. All right, once you get your try these works, you'll be ready for your practice.